Last lesson, we learnt the short method to differentiate. And we're going on from that. There's lots of new techniques that we're going to be learning. Today, we're going to be looking at second and third and more derivatives. So we've got some notation up here at the top. If we're differentiating f of x, you know that we can get f dash x. That's my first derivative. But you don't just have to stop at one derivative. You can differentiate f dash x, and then it becomes the second derivative, and you put two little dashes there. And then it keeps going. Differentiate that, and you get three little dashes for the third derivative. If you were to continue past there, you actually use Roman numerals. Okay, so 4 would be a 1b if you did the fourth derivative. If we're using the y form, it would be dy over dx for the first derivative. Differentiating that, we put little squares on there. You put the squared on the d at the top and the x at the bottom. Okay, so notice where those squares are. And then the third derivative, then it becomes powers of 3 in there. Okay, most of the time, the only ones that are really going to be useful to us down the track are the first two derivatives. Okay, because they're going to help us with some stuff that we're going to be doing with sketching curves later on. There may be some third derivatives just for fun in the exercise that you're going to do, but we won't be really using them later on. You will also note that we can use the operator d over dx. You may see this come up in some of the questions. So if, for example, you know that y is equal to x cubed, we can write that as dy over dx is 3x squared. That's the notation that we're used to. However, instead of the y in the dy over dx, y is equal to the x cubed. So it might be d over dx, and the x cubed, whatever y is equal to, can be written in that brackets. And it means that you're differentiating the x cubed, and you get 3x squared. It's just another way that they can present the questions. Okay, here's one final thing in the theory part. If we have the derivative, so in this last part, dy over dx is equal to 2x, we can go backwards to try to find out what the original curve could have been. So you need to reverse the process of differentiating. So remember, normally we bring the power down the front and subtract 1 from the power. So the reverse is to add 1 to the power and divide by the power. However, also on top of that, because we know when we differentiate, we lose any constants. They just disappear, don't they? If you're reversing the situation, you need to go plus c on there. We call it a family of curves because it could represent a whole bunch of different curves from there because we don't know what that constant could have been. Sometimes they might give you information where you can work out what the c might be, or you just leave it in that form with that plus c on the end. Okay, let's do some questions. Question number 1. Find the equation of the tangent to the curve, and we're given y equals x to the power of 4 minus 2x cubed plus 4x minus 3 at the point 2, 5. Okay, so if I want to find an equation, I need to know a gradient, which means I need to differentiate. So using our short method, our gradient, which I'm going to call y dash, equals. We bring for each term, we bring the power down the front. The 4 comes down. The x is the base, and we subtract 1 from the power, which means it becomes a 3. Move on to the second term and do the same thing. The 3 is going to come down the front and multiply with the minus 2. So it's minus 6x, subtract 1 from the power squared. Next one, 4x. Because it's just an x term, the 4 will stay, but the x will disappear, and the minus 3, which is a constant, disappears. Okay, so there is my gradient function. I specifically want to know the gradient at the point 2, 5, because I'm trying to find a tangent there. That means I just want to take that x value. Okay, it's only ever x values that you substitute in so that I can find that gradient. So I'm going to say when x equals 2, Or in other words, y dash equals, sub the 2 in, 4 times 2 cubed minus 6 times 2 squared plus 4. So that equals 12. The gradient could also be called m. The gradient is 12 at the point 25. I still need to find the equation of that tangent. I know that the gradient, which I'm going to call m, is 12. That's what I just found. And I know that I have a point 25. So I can use the point gradient formula to find the equation. So hopefully you have that formula memorized. I'm going to substitute straight into it. Y take away y1 means y take away 5 equals m, which is the 12, bracket x take away x1, which is the 2. We want to expand that out. And we'll get y by itself and we'll leave it in gradient form. So that's 12x minus 24 plus 5 is minus 19. Okay, so that's the equation of the tangent at that of that curve. Done. Next page, go on to question 2. Just listening, please. Question 2. Find the equation of the normal, okay? Normal this time, not a tangent, so there's a little bit more work involved when it's a normal. I have an equation y equals x cubed minus 3x squared minus x plus 1 at the point where x equals 1. Okay, so it's a lot of the same kinds of steps. First of all, to find the gradient, I am going to have to differentiate it. So y dash equals, for the first term, bring the 3 down the front and subtract 1 from the power, so 3x squared. For the second term, bring the 2 down the front, so minus 6x. And for the minus x term, we would take the minus 1 and the x would disappear. Okay, so that means I can get the gradient if I sub in that x is equal to 1. So I'm going to go when x equals 1, my gradient's going to be equal to 3 times 1 squared minus 6 times 1 minus 1. That equals negative 4. Okay, I need to know the gradient of the normal. So this would be what I would call the M1. That's my tangent gradient. The normal, which we normally call M2, is the negative reciprocal, which is going to be a positive quarter. I know a gradient, and I know to find the equation I'm going to have to use a point gradient formula. There's one extra problem with this question in that I wasn't given a whole point. I was only given an x value. So you have to find the y value before you can use the point gradient formula. Now you sub in, correct, but please be careful where you sub in. Unfortunately, it happens all too often that people will sub that back into the derivative again. Don't sub into the derivative. You're subbing into the original equation to find the y value. So that's going to be y equals 1 cubed minus 3 times 1 squared minus 1 plus 1. And I believe that equals minus 2. So I now have enough information. I have my gradient is positive a quarter, and I have a point, x is 1, y is minus 2. So I can use my point gradient formula. Subbing in, y minus minus 2, the 2 minus will become a plus, equals m, which is the quarter, x take x1, which is 1. Because there is a fraction in there, when there's a fraction, I don't like to have my equations with fractions in them. They're harder to work with. So I would then prefer to go to general form of the equation. So the first thing I would do is multiply the 4 out. So that would be 4y plus 8 equals, and expand the 1 through the bracket, which will just stay at x minus 1. If I'm doing general form, I want the x first and positive. It is positive where it is at the moment, which means everything on the left-hand side of the equation I'm going to move across. So x stays, it'll become a minus 4y, and the 8 become a minus 8 when I move it across, so that will become negative 9 equals 0. If you kept your equation in gradient form with the fractions, it is still correct. Okay, you should be able to work either way, general form or gradient form. If it specifically asks you for one, you must do that type that it asks for though. Question 3, find the first 5 derivatives.
Is it written?
It's not my phone.
Oh.
It's someone borrowed a calculator for their exam. So anyway.
They gave you their phone.
To trade, yes. Okay. So we want to do the first 5 derivatives just for practice. The first derivative, f dash of x equals, bring the 4 down, 4x cubed. Second term, bring the 3 down and multiply it with the 6, minus 18x squared. Next term, bring the 2 down, so 2 times 5 is 10x. Now the minus x term, because it's just an x term, I will get minus 1, x disappears and the constant disappears. So every single time, as long as these powers are in decreasing order here, we're going to keep losing terms from the end. Every time we differentiate, the constant term is going to disappear every time. Okay, so let's do our second derivative, which means I'm going to do 2 dashes up there, and we just do it again from that equation that we just found. So the 3 comes down, times is with the 4, which is 12, x squared. 2 comes down and multiplies with the 18, so minus 36x, subtract 1 from the power. And the 10x, the x will disappear, and I will just have the 10, and the constant disappears. And we do it again. We're going to do a third derivative. So 3 little dashes there for the third derivative. Using the last one that we found, we differentiate again. 2 comes down, times the 12 makes 24. X, subtract 1 from the power is 1. The minus 36x, the x will disappear and I'll just have minus 36 and the constant will disappear. See how it's just getting smaller and smaller every time? We're up to the fourth derivative. So Roman numerals, IV. The 24x, the x will disappear and I just get the 24, the constant disappears.
So if it doesn't have any x, like
it disappears. Yeah, every time you differentiate, it will go. Yeah. And that means for my fifth derivative, there's no pronumerals left, so it would just be 0.
Wow.
Okay, so that's kind of fun, isn't it? Question 4. Find the family of curves. Remember I mentioned that. Family of curves whose derivative is dy over dx equals 5x squared plus 2. This is where we want to reverse our differentiating process. So from the derivative, I'm going backwards to find the y equation. Now my first term is 5x squared. The 5 is going to sit there. The x term, you add 1 to the power, so it becomes a 3, and you divide by that power, so 3 goes on the bottom. Okay, that is how we reverse it. So what about the second term, the 2? Because there's no x there at all, if I'm reversing the process, I would have to add an x back in. And because there could have been a constant, this is why it's a family of curves, we put a plus c to indicate that we know there is a whole bunch of different constants that could go there. We do not currently have enough information to work out what it is, but we identify that there is something that could go there. Okay, you can check if you've got that right by differentiating it again. If that 3 was to come back down here, it's going to cancel the 3 on the bottom and it's become 5x squared again because the power decreases. If I differentiate that 2x, I just get the 2. Okay, so it does work. So look out for those questions when it says find the family of curves. You're going backwards to find what it was before it was differentiated. Question 5, find the family of curves. So here it is again, whose derivative is dy over dx equals x cubed minus 12x. So from the derivative, I'm going back to the y equation. The x cubed, I'm adding 1 to the power, which becomes a 4, and I divide by the power. Same for the next term. Keep the 12, so minus 12. The x, you add 1 to the power and divide by the power. So it becomes squared over 2. And I also have to add on my plus c. Now, we can just tidy up that middle term there. That's y equals x to the power of 4 over 4. 12 divided by 2 makes 6x squared plus c, just to make it a little bit nicer. Last question. Find the second derivative, because you can see the 2 dashes there. Second derivative at minus 2 if f of x equals x to the power of 6 plus 2x cubed minus 13. Remember, you always differentiate first before you ever sub anything in. Okay, so first of all, the derivatives. F dash x, the first derivative. The 6 comes down the front. Keep the x, subtract 1 from the power, so it becomes a 5. Second term, the 3 comes down and multiplies with the 2 to make 6x, subtract 1 from the power is squared. The minus 13 is a constant, so it's going to disappear. Second derivative, it's 2 dashes. Repeat the process with that new equation. 5 comes down and times with the 6 to be 30x to the power of 4. The next term, the 2 comes down, multiplies with the 6 to make 12x. Okay, I have my second derivative. Now I can specifically find that second derivative at minus 2. I can sub that value in for the x. It's always the x value that's in there. So that's 30 times minus 2 to the power of 4. Remember, you always put minuses in your brackets if you're going to put them in your calculator, otherwise it will be wrong. Plus 12 times minus 2. And that equals 456. Okay? Any questions? No.